Guys, in this video, I'm going to take some time to actually talk a little bit about wiring an actuator into a controller. In one of my previous videos, I'd had someone ask about doing some videos on that. And basically what I'm doing in this one, I'm going to show you just an overview of the wiring, and it's some video that I captured that I'm just going to do a voiceover. But what we're doing is we're looking at an incremental actuator as well as a proportional actuator in this video. So stick around, and there is a preference that I have for one actuator or the other, and I'm going to let you know what that is towards the end of the video, so be sure to stick around. Also, guys, I would appreciate it if you would check out all of the affiliate links down below. Like and share the video. That really does help my channel. Also, pick you up some Blackout coffee, guys. It is some great coffee, and it'll help keep you awake on some of those late afternoons and nights trying to get some of this stuff working. But for now, we're going to jump right in and talk about how to wire an actuator to a controller. The first actuator that we're going to be wiring is going to be a proportional actuator. This is a 0 to 10 volt signal, but it's going to be the same even if you use a 4 to 20 milliamp signal. This is the cabling, the wiring for the actuator. It's literally the lead. The red wire is my positive, the black wire is my common, and then the gray wire is our output, or I should say our input to the actuator, our control for the actuator. This is my 24 volts coming into the hot on the controller, and I also have the red tied in with that hot as well to power the actuator. Then my 24 volts AC common is split. You can see here I've just got a jumper here. This is something that you may see in the field if you're working on wiring one of these. And I have got my common, or one side of that common, tied to the common of the controller. The other side of that common must be tied to the common for the output. You can see here, this is configurable output common. Again, this is a Johnson Controls CVM 3050, but it also works the same with the CGMs. You can see that I have my common for the device. You can see there the green light was lit up, indicating the device is currently stationary. But what I'm going to do here is simply override the output of the controller. I'm commissioned in here to where we can do this, and you want to make sure that you have got both the AC and the input or the output common bonded together underneath that terminal, or your actuators are not going to move. Okay, that is something that you've got to make sure of. You've also got to make sure of your polarity as well. If you have one of these actuators that does not move all the way, you've got to make sure that you need to go back to check your wiring. You can see there our actuator, that light is flashing, giving us an indication that it is moving. And just to run through this again, you can see here my power, my 24 volts AC coming from the transformer. I have got it basically just a couple of jumpers here to where I have my common coming into the controller itself. And then the other side of that same common is going over to the common of the output, along with the common wire for the actuator. Okay, that is an important step. And then the gray wire, of course, is my signal. My hot wire is tied in with the hot coming from the transformer, and it is also powering the VMA controller. But again, you got to make sure that you tie those two common wires together, because if you do not, that actuator is not going to function properly. Now this is an incremental actuator, and what we have here coming from our transformer, we have our 24 volts supply and our common from our 24 volts transformer. Again, this is AC, and that's all that we have currently just for this example. I want you to pay close attention to the way that this is wired to the outputs. The white wire is tied to binary output 1, and that's a critical step when it comes to wiring in an incremental actuator. You can see that that binary output 1, that white wire, is actually tied to the common of the actuator. Okay, you can see it there. It goes to terminal 1 of this particular actuator. The clockwise and counterclockwise terminals are 2 and 3. Those are the orange and the blue. And a little bit of confusion with wiring these sometimes is you do not tie the clockwise counterclockwise to the binary output. You tie it actually to the binary output common. You can see here the blue wire is actually tied to the common of binary output 1, and the orange wire is tied to the common of binary output 2. And you can see the terminal numbers there. Again, this is a Johnson Controls CVM 3050, but this is the same when you're working with the CGMs as well. They do switch on that common, so that is a critical thing to remember. If you have one of these actuators that moves in one direction and not the other, you may have that one direction wire on the wrong point. Instead of having it on the common for the output, you probably have it on the output itself. And here I'm just going to do an override to where we can actually see movement of this actuator. And it does work, guys. You know, I'm just going to go ahead and hit the send on this, and it'll take it just a moment, and you will see that actuator begin to move. It's very slow. You can see here, you can see the model number there, 9104 AGA. You know, this is a very common actuator for some of the things that we have, but you can see that that actuator is moving. And again, you have got to have that wire, you've got to have that common tied from the actuator to the binary output 1, and then your directionals will then go to the commons for those outputs. I know it gets a bit confusing on these. You know, we've run into it and done it ourselves a few times to where we've not had it correct, and you always have an actuator that will move in one direction and not the other, and this is exactly why. And just again, show you those terminal numbers for this particular controller as far as where you need to land those wires. But just remember, tie those to the commons of those particular outputs. Now, my own personal preference, if I could choose which actuators that get put in, is the proportional actuators. Because in my opinion, they are easier to troubleshoot, especially if you're working by yourself. It's easy to verify if you're getting your signal. You can literally override a value. For example, what I'll do a lot of times, I'll have an override command to 0, check for voltage. Depending on which direction it's going, you may or may not have a voltage. Take it to 100, and then I'll have check for voltage again. I should have about 10 volts, and then even go like to 50. 50% on your output would be about 5 volts if you're using a 0 to 10 volt signal. So that is my preference, even though there's a lot of systems out there that do use incrementals. But I know that the incrementals can be a little bit more frustrating for some people. But again, you've got to make sure that you follow the proper steps in wiring, and sometimes some of that literature that's out there. I've even seen some of the older literature that comes with some controllers that's mislabeled as far as which points that you tie that to. I think they've got it pretty much corrected, but there again, you just never know, guys. You just got to make sure of where you tie your control points, and to you know, to make it work properly. But if you got an actuator that's incremental, that's moving one direction but not the other, go back and make sure that you're tied to the correct point on that, because more than likely that could be the problem. But guys, that's just a few of my thoughts. That's a little bit about the wiring of actuators. This isn't necessarily going to cover everything, I know, but it's something out there that can help some of you guys out there get started, give you a little bit better understanding as far as how these things work in the field. Again, I just set up just a quick scan with my phone, literally just, you know, something I was working on there in the office, and just did a voiceover to kind of give you guys a little bit better of an understanding. But guys, I hope you liked the video. Be sure to like and share the video. Be sure to subscribe to my channel if you're new here. Again, guys, share the videos because it really does help. Check out all the affiliate links down below. Help support the channel where you can. I appreciate it, guys. Get you some tools, get you some of that coffee. But thanks for watching. Check out the rest of the videos on my channel, and we will see you next time.